Okay, let's find the characteristics of this polynomial function. We have p of x, which is just another way of saying a function, so like f of x, equal to negative 6x to the fourth minus 5x cubed plus 4x squared. And we're asked to determine all the following characteristics. Before we do that, we need to figure out what type of polynomial we have. Because we do not have any parentheses, that means that we have standard form. And that's going to come into play, especially when we find our degree. When we're asked to find our degree, remember that's n, and we're in standard form, so we need the highest exponent. Our highest exponent is 4, so our degree is 4. The number of x-intercepts is the same as the degree, which means, again, our answer is 4. Our max number of turning points is n minus 1, where n is our degree. So we're going to have 4 minus 1, which gets us 3 turning points max. Remember that you do not have to use all of them. You could have 1 turning point or 2. You could even have 3, but you can't have any more than that. You can only have up to the maximum number of turning points, which is always 1 less than your degree. We're asked to determine the end behavior next. End behavior is based on your leading coefficient and your degree. Here, our leading coefficient is -6 because it is on the term with the highest exponent, and we just said that it was negative. Because it's negative, that means that we fall to the right. We end on a negative note because our leading coefficient is negative. So we know we're going down to the right. Our degree is 4, and 4 is even. And that means that our arms are the same because they are even on both sides. When it's odd, they go opposite. So if the arms are the same and the right is already falling, the left has to go down too. So our end behavior is that we fall left and right. You could also say down, left, and right, anything along those lines. But you need to make sure that you state in words what's happening to both the left and to the right. We're asked to find all zeros and their multiplicities. We're in standard form, but we approach it the same way we did with the factored form. We take our function and we set it equal to 0, because remember, zeros are roots, our solutions are x-intercepts. Okay. We haven't really discussed how to do an x to the fourth problem yet, and we'll get into the rational roots theorem and all of that later. But we're going to use what we already know. We have a polynomial, and if we look at this polynomial, there is a GCF because each of the terms has an x, which means there's going to be at least an x in my GCF, my greatest common factor. I'm going to take the lowest exponent, which in this case is 2. And because my first term, my leading coefficient is negative, I know I need to take out at least a -1. I need to see if I can take out something bigger. Smallest of the coefficients or smallest of the numbers is 4. 4 won't go into 6 or 5. So what else goes into 4? 2. 2 will go into 6, but doesn't go into 5, which means that the only GCF they have is 1, and I need that negative on there. We're going to factor out the GCF, and if you don't remember factoring the GCF, we are essentially going to take each of our terms and divide by the GCF we're taking out. And I'm shorthanding, instead of writing negative 1x squared, I'm writing negative x squared. And the negative x squared comes out in front of the parentheses. Negative 6x to the fourth over negative x squared. The negatives cancel, and 4 minus 2 means that we're going to have an x squared with our 6 in front. Negative, negative gets us a positive 5, and 3 minus 2 gets us an x to the first. Positive 4 divided by negative 1 gets us a negative 4, and our x's cancel out. We're still equaling this to 0. We're not done yet because the inside is not factored. I'm going to try to factor it. If you don't want to factor it, go ahead and use the quadratic formula. A would be 6, B is 5, and C is negative 4. Remember, we're ignoring that negative x squared until we're done inside the parentheses. If you're factoring, you would need a product of A times C, which is 6 times negative 4, which is negative 24, and a sum of B, which is 5. Your two magic numbers for which you are looking are going to be 8 and negative 3, because 8 times negative 3 gets us negative 24, and 8 plus negative 3 gets us 5. So continuing our factoring, I'm going to have x plus 8 times x minus 3. Have to divide by our a, that coefficient, because you can't do bottoms up method without a bottom. Reduce your fractions. You can use your calculator. Make sure that you convert back to a fraction when it gets you a decimal. Should have x plus 4/3 times x minus 1/2. Bottoms up method says bring it all back up out of the basement. And we get 3x plus 4 times 2x minus 1 equal to 0. And you're not going to get in trouble from your mom because you're not going to leave your sibling at the mall. You're going to bring them home with you. So we pick them back up to bring them home. And now we are in factored form. Notice all the parentheses and everything's multiplied together. So now we're actually going to solve. We have negative x squared equal to 0. We have 3x plus 4 equal to 0. And we have 2x minus 1 equal to 0. In our first problem that we're solving, we would divide both sides by negative 1. X squared is 0, which means that x is 0. In our middle equation, subtract the 4 to get 3x equal to negative 4, and x equal to negative 4/3. And finally, add the 1, we get 2x equal to 1, which means x is equal to 1/2. We found 3 distinct x-intercepts, but notice that our degree was 4. We still need to go and find the multiplicities, and when we find all these multiplicities, it better equal our degree. All right, so x equal to 0. that x equal to 0 came from negative x squared equal to 0, which means that our multiplicity is going to be 2 as the x squared. In our 3x plus 4, that was to the first power, which means our multiplicity for negative 4/3 is going to be 1. And the same thing is going to happen for our x equal to 1/2. The other way that you can do it, if you don't want to go back to the factored form, how many times did you find negative 4/3? How many times did you find 1/2? You only found each one time. So now we have our 3 distinct x-intercepts, zeros, roots, solutions. And if we add the multiplicities, 2 plus 1 plus 1 gets us the 4 that we had as our degree. Now that we found the x-intercepts and their multiplicities, we can determine the behavior of the graph at the zeros. Remember, this is not end behavior. We already did that. That's rise and fall to the left and right. Here, we want to know if the graph touches and turns, which remember is also bounce, or whether the graph crosses through the x-intercept. Remember, touches and turns or bounce is when you have an even multiplicity, and cross is when you have an odd multiplicity. Let's go back and look at our function, or not our function, our x-intercepts. If we look at x equal to 0, he has a multiplicity of 2, which is even. Because his multiplicity is even, that means the graph touches and turns at x equal to 0. X equal to negative 4/3 and x equal to 1/2 both have a multiplicity of 1, and 1 is odd. That means that the graph is going to cross at both x equal to negative 4/3 and x equal to 1/2. Remember, you don't care whether the actual x value is even or odd. We care about the multiplicity, but we write down the x value. Next, we need to find the y-intercept of our function. Remember, that means that we are going to plug in a 0 every time we see an x in our function. So we're looking at p of 0 is equal to negative 6 times 0 to the 4th. I'm plugging into the original. You could plug into factored form if you really wanted. Minus 5 times 0 cubed plus 4 times 0 squared. If you plug this into your calculator, you wind up getting 0, which means our y-intercept is the ordered pair 0, because that's what we plugged in for x, comma 0, because that's what we found for y. Now, contrary to what you may think from this example and the previous one with factored form, not all of your y-intercepts are going to be 0, 0. It's just a fluke that it happened in these.